That's a 130 microfarad, 250 volts AC, run capacitor. And that (250 volt, 560 microfarad regular electrolytic capacitor. Okay, and that's a rectifier, 100. It's a pretty good one, and it's on a nice heat sink. DC out, plus and minus 120 hertz pulses. AC in from the grid. This will convert alternating current to direct current pulses at 120 hertz, or 120 pulses per second, at about 80 watts. I'm going to use this to run a DC radiator fan for a racing car that I purchased for about 50 bucks on eBay. It can handle 200 watts, the fan. It's a 16-inch diameter fan, and they're available on eBay. This will run the fan, and this power supply will run and run and run, and you won't have any problems. This capacitor drops the voltage down to about 30 volts or 28 volts. By the time your wiring gets to the fan, the voltage will be 24 volts. And once the load is on, it'll drop to 12 volts or 14, and it'll hold about 14 volts to run a 200 watt fan, radiator, DC radiator fan. That's just a regular electrolytic capacitor. Now I'm going to show you the circuit. See, alright, I'm a pet iguana. I think it's a female. Its back was fucked up. That's the circuit. It's a simple circuit. You see those 4 capacitors, 25 microfarad? Those are the ones that drop the current, drop the voltage from the grid from 120 volts to about, well, the higher the capacitance and the voltage rating of the capacitor you use, whether it's electrolytic or not, the more the voltage will drop. I've dropped the voltage down to 4 volts. But then very little current gets to the battery, and you have to add more capacitors to the you see the 25 microfarad by itself? That one right there is the amperage. That determines how much amps are going into the pulsing. And 25 microfarad will give you about 30 watts or 20 watts after you drop the voltage. But if you don't drop the voltage and you take out those capacitors in the center, take those out and keep the circuit without those capacitors in there, then it will pulse at 160 volts, and your amps will go up, of course, because your voltage went up, and you can now push more current into whatever DC load you got, a battery, a fan. This power supply is flawless. I've purchased multiple DC power supplies and they all burn out. And this thing, if you get a nice solid high amperage rectifier, then you know, they'll run forever, I think. And they're more efficient using your energy. This circuit uses your energy more efficient, so you'll actually use less power, and you'll save power by using power this way. Converting AC to DC saves a 90% of energy. So when you run motors AC, you're using all that energy, and you know, and honestly, you're not getting any more torque for the current than you could with a DC permanent magnet motor. You can achieve even more torque with less current on your circuit. In other words, using less power with a permanent magnet DC motor. This thing will also run a, you know, a Bedini motor if you want. Yeah. So, but they use AC motors with induction coils to act like magnets once they're energized, instead of permanent magnets, and that's energy loss right there. That's why they're not efficient, and they're no more powerful. If you replace the induction coil with real magnets, then you don't have to use power anymore for that, and now you have even more a torque output. So in sense, you have more energy for your bang for your buck, and we are just throwing away our money on electricity by using everything AC this, AC that. All our blenders are AC. You know, they're starting to make blenders that are DC, and you'll notice they run quieter and they reach higher RPMs, and they don't heat up. You know, look at LEDs are running off pulses. You know, LED lights, they pulse. You know, and there's some controversy about the frequency and brainwashing people and the blue light and all that, but hey, they can change that to another spectrum that will, you know, enhance your intelligence. So you know, you can be digging that yourself. But LEDs, they oscillate, or they pulse at high frequencies, much higher than 120 hertz. But point is, pulsing DC is where you have energy savings and efficiency for all your needs in the realm of using electricity to run a device, whatever that device is. Over and out. Mike does. Oh, let's go back to the one more time. Hey, goodbye there. Let's go back to this circuit is right there. Okay. You see a 25 microfarad in the circuit. Well, I used there you go, 560 microfarad, 250 volt electrolytic with a 130 microfarad, 250 volt run capacitor and a 150 amp rectifier. Those are the parts I used for this circuit. That 25 microfarad there is a 135 microfarad run capacitor, and these four, instead of four, I just have one, and it's a 560 microfarad 250 volt electrolytic capacitor. It drops the voltage from 120 volts down to about 30 volts if you build it with those parts. Okay, Mike does.